This video is about how to find a p-value given a t-value or a z-score, and I'll go just in a little bit of how to, whether you're going to reject or fail to reject the null hypothesis, and when to use a t and a z. When do I use a t versus a z? I use a t when when I'm exploring some number, not a ratio, not like 0.36 or 12 over 15. When I'm exploring a number, like in the first question on this worksheet, the question is the average score of 500 or greater than 500? That's a number. And if I don't know the population standard deviation, or if I'm looking at a number and I know the population standard deviation, if I have a small sample size, that's when I use t. I will use z when either I know the population standard deviation with a number and I've got a large sample size, or if it's a ratio, then I will use z. And so here in this question, I've got a number, 500. I don't know the population standard deviation, so using the t-table, I calculate the t-score. This video is not about that. I got 2.909. I can either look at a t-table and find a critical value, or I can compare it to a p-value. I'll show you how to do the p-value in a second, but I'm going to give this information. If the p-value is less than my significance level, then I will reject the null hypothesis. There's convincing evidence of the alternative hypothesis. If the critical value, if I'm doing a t and the critical value I find in the t-table is less than my t-value, then also, same thing, I will reject the null hypothesis. There's convincing evidence of the alternative hypothesis. I am using on this question my significance level of 0.05. I would use a 0.01 if it's a very critical thing for, say, a lot of money on the line, or whether a business is opening or not, and that would I use 0.01. I'd use a equals 0.001 if life was on the line. Like I wanted to make sure I didn't make a mistake in rejecting the null hypothesis. Maybe it has to do with something on a space rocket's engine life, and if the engine fails because I've miscalculated that, people will lose their lives, or trillions of dollars will be lost. Who knows? Maybe it's, the world, all of human population has to move to another planet. I'm doing some statistical analysis. I better use a is 0.001 or maybe even lower in that case. But anyway, this one doesn't specify the significance level. I'm using 0.05. I have my t-score of 2.909. So now I'm going to go to my TI-84 calculator, press second, Vars, and I'm going down here to T CDF. And I always forget what CDF stands for, cumulative distribution function. So this is the T, cumulative distribution function. I go there. And now, notice this is a positive T value. If the T or Z value is positive, I put it first in the lower bound, and then the upper bound I'll put a large positive number. If the T or Z value is negative, I put a large negative number in the upper bound, and then the negative T or in the lower bound rather, and then the negative T or Z in the upper bound. All right, so this one has a positive T. I'm going to put 2.909. Let me clear this. 2.90. Whoops. I put 2.909. Then I need a positive, very large positive number. I'll use 1 second E 99. That means 1 times 10 to the 99th power. Probably I could put, well, I know I can put 1,000 there too. The degrees of freedom is the sample size minus 1, and this one, the sample size is 60. So I'm going to subtract 1, 59, and then I go down to paste it, boom, I get my p-value, 0.00255. In this case, p is 0.00255. My significance level is 0.05, 0.00255. That's the p-value, is less than the significance level of 0.05. P is less than A. I would reject the null hypothesis. There is convincing evidence of the alternative hypothesis. In this case, there's convincing evidence that the actual mean for the school, the mean SAT score, is bigger than 500. I think it's only for the math section. But anyway, P is less than A. I could also look this up on a t-table. If I'm looking it up on a t-table, I have to know if I'm doing a 1 or 2 tail experiment. Since this one I'm only interested in greater than 500, that's one-sided, one tail. If it was not equal to 500, it would be 2 tail. I look for my significance level, 0.05 right there, and then I scroll down to where I have the degrees of freedom, which is 60, and it shows 1.671. The actual degrees of freedom is 59, which is a little bit less. You can see at degrees of freedom 40, it's going up 1.684. So I'm going to say this is probably more like 1.672. It's bigger than 1.671. But anyway, 1.671, or 1.672 rather, is less than, that's the critical value, is less than the t value, 2.909. And again, critical value less than t, same conclusion. Reject the null hypothesis. There is convincing evidence of the alternative hypothesis, again, in this case, that the mean for the school SAT math score is greater than 500. Okay, I'm not going to go too much into those conclusions in the next one. I'll just show how to get the z-score. Why am I using a z on this one, this next one? Because it's about a ratio, 25% or a percentage. This is a two-tail test because it's not equal to 25. So it means it could be bigger or smaller. So whatever value I get for the p-value, I'm going to double it, because when I do it on a calculator, I get a one tail. I am not going to use the t this time. I'm going to use second Vars, and when it says normal, whoops, what happened? Let me clear it, I went to the wrong place. Second Vars, I go down, what's going on here? Okay, there it is. Normal cumulative. Oh gosh, I always forget what this is. Normal cumulative distribution function. I don't know why I can't remember that. And then I'll enter it. And now, check out this one. My z-value is negative. So when it's a negative z-value, I'm going to put a very small negative, a very large negative number, and then on the lower bound, is it the lower bound that comes, whatever comes second, I'm putting the negative z-value. Let me find it again. Yeah, the upper bound. The lower bound is a very large negative number. I think this time I'll put negative 1,000 just to show that that works. And then below I will put the negative z-value, negative 1.491, negative 1.491. I need a mean for the normal distribution. Mean is 0, standard deviation is 1. I will paste, and then I hit enter again, and I got an error. Error syntax. Why did that happen? Well, I'll show you why that happened in a second, and I'll show you how to fix it. Let me clear, go to second Vars. What's going on here? Clear, second Vars. Somehow I'm not getting there. Second Vars. Okay, there we go. Normal, enter. Now, I used the minus sign, which is an operator like 10 minus 9. I need to use this negative. The negative is next to enter, not the minus sign. Otherwise, it gets an error. So there's the negative. Again, I have a negative z, so I have to put a very large negative number first. I'll put negative 1,000, big enough. And then I'll clear this one and put negative 1.491. Whoops, came out to, didn't get the 1. Negative 1.491. Mean is 0, standard deviation 1, down to paste, boom, boom. I get 0.067. Because this is a two-tail test, I'm not going to multiply that by 2. I get 0.13596. And you will see that 0.13596. Again, I'm using A as 0.05, 0.13596. This one came from the P table, so it's not exact, 0.1362, but still in this very, very close. Is greater than 0.05. If it's greater than, then fail to reject null hypothesis. Not convincing evidence that the alternative hypothesis is true. In this case, that the proportion of D's differs from 0.25. Okay, so I got that one. Here's another Z. This one is a proportion again, so I'm going to use Z. I got a Z score of 0.1155 right there. Again, if Z is plus, I'm going to put the Z score first in the, I always forget which one goes first. Is it upper or lower? Let me go down here, Vars. And I'm going to normal, enter. I'm going to put the z, if it's positive, in the lower, and then a very large positive number in the upper. So my z-score here is 1.155. I don't have to worry about that minus thing or negative thing. Why aren't the ones going in? 1.155. Down here I'm going to clear it. I'm going to put a very large positive number. I'll just use 1,000 this time. Mean is 0, standard deviation 1. Paste it, and I get 0.12404. And again, this one said use a equals 0.05. So this p-value that was used by the instructor is from the table, so it's approximate. I got the exact number on the calculator. 0.12404 is greater than the significance level of 0.05. So again, check this out. I can get there. When p is greater than my significance level, fail to reject null hypothesis. There is not convincing evidence of the alternative hypothesis. In this case, the alternative is that I think the percentage of tennis games this person won, tennis matches, is greater than 60%. So in this case, fail to reject. There is not convincing evidence that Renee won more than 60% of the matches. But anyway, that's how to use the TI-84 to find p-values from t's and z's, and then also how to use the t-table if you have the t's to also come to your conclusion.